Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see differentiability. Okay, so you might be thinking, what is differentiability? What is differentiation? What is applications of derivatives? A lot of persons, okay, a lot of people are thinking that all these three are same. Okay, all these three are same. Well, the answer is no, not all of them are same. There is little bit of difference. Okay, there is little bit of difference. Like if you want to take them as same, there is no problem, but there is little bit of difference. That is, if you are using this formula, okay, if you are using this formula, and then if you are differentiating something, okay, and then if you are differentiating something, then it is known as differentiability, okay. Or if you are already some formulas would have been given to you all, okay, already some formulas would have been already given to you all, and if you are using those formulas and then differentiating, then that is known as differentiation, okay. I know nothing makes sense. Well, don't worry, as the time passes it will all make sense, okay. Then applications of derivatives is where you are actually using this formula in real life, okay. You are just relating every event that is from this formula and then in the real life, and then you are getting the answer, okay. Applications of derivatives is the biggest chapter in entire 12th. Like that we can keep it as, okay. So like that you can keep it as, because there are lots of topics, okay. So yeah, now everything will not be that much clear. Everything will not be that much clear, but we will make them clear step by step by step. Okay. So first I will erase this. Okay, and don't worry, now you don't by heart this formula. Now there is no need of this formula because I will give you along with the derivation itself. Okay, so this is not required. Okay, so this is not required. And I have notes over here in my tablet. I'm going to use those notes and then I'm going to teach. Okay. So first I will give you one example, okay, where we are using in our real life. Why do we have to study this? Basic idea I will be giving you, okay, I will be providing you. Then we will get to go into this topic. Then we will be going into this. Then we will be going into this topic, that is differentiability, okay. And if in case you are an NCERT student, then you might be wondering, only 2 to 3 questions are there. Do I have to spend like around 1.5 hours to 1 hour 45 minutes for this topic itself? Well, yeah, you have to. Yeah, you have to, because if you want you can learn, if you don't want then no problem, okay. But it has a lot of basic things that you want, okay. So first I will give you that basic knowledge that I said, okay. So you are having a square, okay. Now you have to differentiate, okay. Now you have to differentiate x square. We all know that in our 11th standard even we have studied that differentiation of x square, the differentiation of x square is going to be 2x. This one we have all studied, this condition. But how the differentiation of x square is going to be 2x, and what the hell is differentiation? We just use the formula that is given and just we get the answer. But when we just understand till to the basic core, then you will be having some basic idea, so that the roots will be very strong and the stem will be also growing big and very healthy, okay. So we have this one square, okay. So what is this? X square is what? X square is x into x. Yes, right. So x square is also what? It is the area of square. You can take it as area of square if in case x is the length of the square. So, and imagine this is a square, okay. Well, it can be also rectangle. I'm not measuring it, but okay. Imagine this is a square, okay, and hereby it is x length, and also hereby it is x length, okay. Now what I'm doing is, okay. Now what I'm doing is, I'm making the square bigger, okay, more than this, okay, more than this. So now I have this square, right? Okay. So this square, I'm now making it bigger, little bit bigger, okay. So we will make it bigger. You can take also cube if you want, you can take anything you want, you can take circle, but square is the best idea or best way to understand, okay. It is the best idea that I have ever got, and also it is the best way to understand, okay. Now I've made it a little bit bigger, okay. Now what I'm going to do is, which color? This color, okay. I will erase this, but you all know that, okay. At last we are going to get 2x as an answer. Just this is also not that good in handwriting, so I'm going to erase that, okay. So the increased length is there, right? This length is what has got increased, okay. From this length, okay, from this length I have increased a unit length, and that unit length is going to be dx, okay. So that unit length is going to be dx. Now here, over here also I have increased some length, you can all notice that, and that length is also going to be dx. That is just the property of square, right? Okay. And now, okay, I want the area. Okay, I want the area of this one. Okay, I want the area of this increased path. That means this path area I want. So how can you do? Okay, either there are some ways. Now I'm going to consider one way, and that way is what? The opt way, in order to understand differentiation or differentiability. Okay. Now what we are doing is, I'll say you will even answer it. Okay. So first we will be cross-secting it into different parts. Okay, we will be cross-secting it into different parts like this. Okay. Now we will go into its area. Okay. So this one area. This one's area. Then this one's area. Okay, then this one's area. Okay. Now what we have got is, see, this one is dx in length. Okay, this one is dx in length, and also this one is going to be, see, this one like this it is, I have written like this. Okay, that's the difference. Other than that, no difference. Okay, and then this one is going to be x. Okay, this one is going to be x, and also this one is going to be x. That means I'm just talking about the length. This one, okay, for this one, this is also a square, but I've drawn it like a rectangle. It is going to be dx and then dx. By the way, it is just a zoomed version, okay, but in reality, if in case this is what the square is, in reality if this is what the square is, then the amount, that means, wait, I have a sharp corner. Okay, so if in case this is what the square is, then the zoomed, then that means the increased length is going to be only like this much. Okay, only like this much. That's it. Even not even this much. Still more smaller than this one. Okay, like this one. It will be, but this is just a zoomed version. You keep it as the zoomed version. Okay, this is going to be very, very less. Okay. Now what do I want? I want the increased area. That means this area. So what can I do? I can calculate this one's area, this one's area, this one's area, and I'm going to add this. Okay. So that means increased area is equal to what? Now you can multiply it into, see, this into this one. So which is going to be x dx plus again this into this. Okay, so x dx, that is what the formula for length of the area of the rectangle, right? Okay, so here also this into this, which is going to be dx square. Okay. Now you have to note one thing. So as I said that this increased length is actually a zoomed version. Okay, so this is going to be actually, in reality this is going to be very, very small, but here I've drawn it in a bigger way. Okay, so that this length, okay, this area is going to be very small. This area is actually going to be very, very small. So what I'm going to do is I'm going to neglect it. Okay, so I've neglected it. Now the increased area is what? Now the increased area is going to be is equal to 2x into dx. Okay, 2x into dx, isn't it? Okay, isn't it? And let us keep that. Okay, let us keep that this area is going to be, this area is there. Now this area is what? X square. Okay, so I will use this color. Okay, and then I will keep this increased, or yeah, x square I can keep it as, and this increased length is there, right? This increased area, not length, sorry, this increased area is there, right? That one is equal to dy. I will keep it as dy. Okay, now then it will be what? It will be dy. Okay, so then at last we have got the formula, that is dy by dx is equal to 2x. Yes, yeah, this is what it is. Okay, you might think, wait a minute, what is this? Just some, you have calculated the area and this is what it is. This is how they calculate actually. Well, some spark you will have in your brain, right? Okay, now you are having some spark in your brain about what is differentiation. Actually, this is differentiation. As I said, everything is interlinked. I will at last tell you the difference between differentiability, differentiation. Okay, still now, okay, for the purpose, for the sake of understanding, okay, there is no such word as understanding, right? Okay, so for the sake of understandment, you just keep it as both differentiation and differentiability are the same. Okay, both the differentiation and the differentiability are the same thing. So okay, so increased area is equal to x dx plus x dx. Now we have got like this. So what does it mean? Okay, it means that this differentiability, okay, so this differentiability gives you the idea about how much area, okay, how much change, okay, how much change will be happening. Okay, see, for an example, let's just keep that this is a square. Okay, this is a square. Okay, and this square is very hungry and it is eating everything, so because of that it is becoming bigger and bigger and bigger. Okay, so per second, okay, for 1 second it is increasing like this, then for the next second it is increasing like this, okay, then for the next second it is increasing like this, like that. The square is, okay, we will just keep like it is increasing like this, then like this, okay, then like this, okay, like that. The square is actually increasing in its size. Okay, so that increase, okay, that increase, you are actually calculating that increase only. Okay, increase in something or decrease, okay, can be both decrease or increase, that we don't care. Okay, but we just care the change per second or per minute or change per length. Okay, that is what you are calculating. Okay, what is happening in that particular time or in that particular area or in that particular distance, what is happening, what is the change, that is what differentiability is. Okay, well, still a lot of things might be confusing. I'll be giving you the idea second by second. 1 second. Now, okay, we will apply this into our real formula. And then we will check what do we get. Okay. Actually, when you understand better than others in the class, then automatically you will be interested in the subject better than anyone. Okay, more than anyone, not better than anyone, more than anyone. Okay, so now for an example, okay, okay, so for an example, this is what the square is, okay, and then the increased length of the square, okay, and then the increased length of the square is this much. Okay, is this much, which is over here it is 2 meter, and over here it is 1 meter, over here also it is 1 meter, okay, over here it is 2 meter, okay, also, okay. Now you just check. Now we will calculate the increased area. It is very simple, but this method only you have to use. This method only you are supposed to use. Okay, more than other than this method you are not supposed to use. Okay. See, actually, also they have given you this one. Wait a second. So actually, in the beginning, you can very easily say that we can calculate. No, this method you can like cut this, okay, then you can see, or instead of that you can also use the general method. That means, see, what we are trying to do is we are trying to get into our brain that whether this is correct or not, what we did is correct or not. Okay, let us check. First we will use a general method or mathematical method, that is we will calculate by using these numbers, then we will be calculating that using this, okay, formula, okay. So the actual length, first what was, okay, so then dy is equal to the increased length, okay, the total area. So it's coming in my mouth as length, okay, it's area. Okay, so the total increased area minus initial area. So what is that? So dy is equal to total increased areas. Here also it is 3, here also it is 3, so which is going to be 9 total. Okay, so 9 minus initial area. What is the initial area? 2 into 2, which is going to be 4. So here it is going to be 4. So here then dy is going to be 5. Okay, so here dy is going to be 5. This is what it is. Now we will calculate that by using the formula. Okay, we will calculate that by using the formula. So what formula do we have here? We have this formula, right? We will put this over here. Okay, that is dy by dx is equal to 2x. Okay, is equal to 2x. Okay, so you have got, you don't know dy, you have to calculate dy only. Okay, so dy is equal to 2 into, what is x? X is going to be this length, okay, which is 2. Okay, and over here dx is going to be the increased length. As I said, it is going to be 1. So dy is equal to 4. Here we have got error. Over here we have got error. Okay, you just check over here and here, there is actually 1 unit error. Okay, there is actually error. There is error. Okay, in terms of percentage, I'm going to calculate this error. So in terms of if you are calculating it in terms of percentage, then it is going to be, okay, So error percentage. Wait a second. I'll use a different color to differentiate. Okay, I think in 11th standard first chapter of physics we have studied how to calculate error percentage. It is going to be 20% over here. Okay, over here if you are calculating the error percentage, then over here it is going to be 20%. Okay. You might think, wait Kanan, then till now what I've learned, okay, whatever you said, blah 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 stories, so all of them are wrong? No, it's not wrong. Actually it is because you have chosen here dx as 1. You have chosen here dx as 1. If this dx is more than 1 meter, that means you just take that. This is 1 meter, right? If in case you are taking dx more than 1 or bigger value, if you are taking dx as a bigger value, okay, if you are taking dx as a bigger value, 1 meter is very big, right? It is 100 centimeters. Okay, 100 centimeters isn't just a small unit. 100 centimeters in sense, this is 50 centimeter scale. Okay, so that means from over here to over here. Okay, that means till the end of the scale you have to calculate this. Check. Okay, then it is 100 centimeters, which is 1 meter. Okay, which is actually very big. Okay, so if I'm taking more than 1 meter, let us take like 1.2 meter, then the error percentage will be still increased. Okay, so I can say that dx, okay, is directly proportional to error percentage. Okay, if the length of dx is greater, then the error percentage will be also greater. Okay, so which means if you are trying to get this dx as minimum as possible, then only this error percentage also will be very less. Okay, now I will give you with another example, that is, now I'm going to try with dx as, okay, now we will try as dx is equal to 0.5 and x is equal to 2 meters itself. 2 meters now? 2 meters itself. So same thing, okay, so the same thing. This is going to be 2 meters. Okay, here also it is going to be 2 meters. Here it is going to be 0.5 meters. Here also it is going to be 0.5 meters. Okay, so the real length. Okay, now I'm going to use by our mathematical method. Actually, this is going to be our mathematical method, and this is going to be our this is our mathematical method. This is the differentiation method. Okay, so coming to differentiation method. This is actually pretty simple by using differentiation method, you know. So because dy by dx is actually 0.5, I can write 0.5 in terms of fractional, which is going to be 1 by 2. So 1 by 2 I can write it as 2 into 1. Okay, like this I can write, right? Or okay, it's okay, I'll write here as 1 by 2 itself. 1 by 2 is equal to which is 2x. Okay, so 2 into 2, so which is equal to, now I'm ready to do fractional once again. This is going to be 2 only. Okay, so dy is going to be 2. Okay, now by using our this method, okay, so now you are going to calculate it. So here it is going to be what? Here it is going to be, wait a second, here you have calculated it by using, and hereby it is going to be 2.5. Okay, 2.5 into 2.5, okay, minus, okay, here we will keep it as 1, 1, here we will keep it as 2, okay, because these two are not same, right? These two are not same, right? So I cannot keep it this and this as dy, okay, so to minus 4. Okay, so what value is it going to be? It is going to be 6.25. Yeah, 25 square is going to be 625, right? So 6.25 minus 4. So here dy1 is going to be, okay, the dy1 is going to be 2.25. Okay, 2.25. Now if you are calculating the error percentage, it is going to be, error percentage is going to be just 11%. So the error percentage is going to be just 11%. Okay, you can see that since I've reduced in the length of dx, also the error percentage has got retarded, and here also error percentage has got retarded. Sorry, comparatively, when you are comparing here, and then this case the error percentage has got retarded because of decrease in the length of dx. Okay, so if, okay, so note this one point. Okay, so you are going to note this one point. That point is if dx is actually tending towards 0, then the error percentage, okay, then the error percentage will be also tending towards 0. Then the accuracy will be equal to, then wait, then dy1, okay, dy1 will be equal to dy2. Okay, dy1 will be equal to dy2. Two, 1, 1, 1. Okay, so this is what it is actually. If in case this dx is very less, okay, if it is very small, then the accuracy will be very high. Okay, so you can take that dx is inversely proportional to accuracy. Okay, so dx is inversely proportional to accuracy. Okay, for an example, you just take it as 0.001 meter. Okay, you just take this as 0.001 meter. Then the error percentage will be 0.024 percentage. Will be 0. Okay, will be 0.0 percentage. Yes, 0.024 percentage. Will be 0.024 percentage. Now this is what the thing is. See, as you take this lesser and lesser and lesser, and the error percentage will be reducing. Okay, so from this, okay, you can very easily say that, okay, you are getting some idea, right? Okay, now I'll be giving you still more better idea. That is, see, actually this derivation, okay, this derivation is here, right? This dy is none other than the differentiated form. That is, you can see here, where is it? You can see that dy by dx is equal to 2x. Okay, dy by dx is equal to 2x, which is, this can be written as f dash x also. This can be written as f dash x, where f of x is equal to x square. Okay, I know nothing makes sense actually, which means this is what your function is, where your function is x square. Okay, where your function is x square. Now this x square function, okay, now this function, when you are differentiating this function, then this f of x can be represented as f dash x. When you differentiate it, okay, you can represent it as f dash x instead of writing it as fx. Okay, or also you can write it as dy by dx. Okay, dy by dx, because I have taught you already that, okay, f of x is equal to y. Okay, f of x is equal to y in relations and functions. It was a very lengthy video, one of the most lengthiest video that I have ever made is differentiation, and I think it was about 5 hours. Okay, but you will be seeing it in part wise, because even I have taken it as part wise. It has taken me about 3 days to take that video itself. Okay, f of x is equal to y. So while differentiating, what does differentiation mean? It means that, okay, d f of x by dx, okay, which can be written as f dash x, or you just, in place of f of x, okay, in place of f of x, what you are going to write is just write y, so which is equal to dy by dx. Okay, which is going to be equal to dy by dx. Okay. Now you come here. Now when you differentiate it, what you will be getting? You will be getting it as f dash x is equal to 2x only. isn't it? You'll be getting this one only, right? Okay, that is what I've written like this. See, I've used this one like this. Okay, so actually, or like this also I can explain. Okay, like if you have to do like this, then in the increase, then that one can be calculated like this also. It's one way. Okay, that is one way. Or next is tangential method. Okay, don't worry. By using this tangential method only, we are going to use it. We are going to solve every formula from this lesson. Okay, and also we are going to derive the formula also from this way only. Okay, so tangential method. What does it mean? It means that you are going to take x square. Okay, what is x square? It is a parabola, right? Okay, I'm not that good in diagrams and I don't even have here parabola, I think. Do I have here parabola? No, I don't have parabola. Oh. Okay, so imagine that is your parabola. Okay, imagine that is your parabola. Okay, so in this parabola, what is your formula? Your formula is going to be x square. Okay, x square is the formula for this parabola. X square, okay, for parabola, yeah, parabola, which is actually upward, then other than this. Yeah, so see, this is your parabola, and if you have to actually calculate its tangent. Okay, what is tangent? Tangent is a line that just touches one point of the curve. Okay, just touches like this and it goes. Okay, so that means over here it will be touching. Like this, just at one point will be touching and will be gone, just like that. Okay, so this is going to be x square. This parabola's equation is going to be x square. Okay, and then this line's equation is going to be 2x. This line's equation is going to be 2x. Okay, like this also I can say. Okay, like this also I can say, that is, see, this total equation of this parabola is going to be x square, and then this line's equation is going to be 2x. Okay, so from this is also a way like how I can explain. That is actually, okay, see, I will first read the mathematical derivation. By the way, mathematical authentic Oxford not definitions really sucks. You cannot understand anything from that. Right. The derivation shows the sensitivity of change of a function's output with respect to the input. Derivatives are a fundamental tool of calculus. What is that? Okay, so this is one way. Okay, so x square, 2x. Okay, so next one method of explanation that I can give is not only like this. For example, you just take a slope. Okay, any slope or any curve, anything. Okay, for example, this is how the curve is. Okay, like this the curve is, or like this. No, it is dancing. Oh no. Okay, like this it is. Now this equation of this curve is going to be f of x. Okay, then it's f dash x. Okay, then if you have to calculate its derivatives, very simple. All you have to do is you have to calculate the slope. You have to calculate this, not the slope. What is the tangent? You have to calculate its tangent. You have to calculate its tangent, which is going to be f dash x. Okay, which is going to be f dash x. Okay. So tangent is the f dash x. So if you are taking it as f of x, then this is going to be f dash x. Okay. Then also, actually, now I will be giving you what is that curve. Okay, now I will be saying to you what is that curve. Okay, everything I will give you. Okay, for an example, now just imagine. Okay, your enemy is there. Okay, your enemy is there, and that enemy has got stuck in a tsunami. Okay, even Mother Nature does not like your enemy because that much sinister your enemy has done. Okay, that much sinister your enemy has committed, so that now he has got stuck in the tsunami. Okay, so now government is trying to save him. Okay, that is what government do. Okay, they will try to save the bad people and they will leave good people. Okay, that's not something we are going to talk about. Now the government is trying to save him. For that, what government is doing? For that, government is actually trying to calculate the change in the speed of the tornado or the tsunami. Okay, well, somehow, don't worry, your enemy died. Okay, the government failed. That is also one of the most primemost job. Okay, you just check. Okay, you just check. So this is what the graph of that tsunami's velocity or acceleration. We will keep it as velocity. No, I'll keep it as. Okay, this is what the graph of tsunamis or tornadoes velocity. Okay, this is how it is going. You just keep it, no problem. Okay, everything is creativity. You just keep it like this is how it is going. It is highly oscillating. Okay. By the way, what discontinuity it is? I have also taken seminar over continuities, right? Over there, discontinuities, and I said 3 types of discontinuities. Amongst them, this is one type. What is that? This is oscillatory discontinuity. Yeah, this is oscillatory discontinuity, and your example is going to be cos 1 by x and then sine 1 by x. And I have given you very good explanations also for that. Okay. Now you check. Okay, so in this second, now what you want to do is you want the time when he has passed away, because you want to celebrate. Okay, so for that you are actually having the need to know the time when he has passed away. Okay, so let us keep like this is that particular time. Okay, this is what that particular time is. Okay, so this is what that particular time. So we will keep that this time as what? 4:20 p.m. Okay, or AM. Both are okay. AM. What a problematic timing. Oh God. Okay. Now in this time, this is what the velocity of. Okay, this is what the velocity of. This is what the graph of velocity of that tornado is. Okay. So what do you want is actually you want to calculate what is the change in the speed. Okay, why did he die exactly in this time? Okay, why did he die exactly in that time? And what scientists are saying that it is actually because of sudden change in the velocity. Okay, sudden change in the velocity. Well, yeah, everywhere there is sudden change because it is oscillatory discontinuity. So there will be like that when it is oscillating graph. It will be like that only. But okay, scientists are saying. Okay, now you have to calculate the change in the velocity with respect to that time. Okay, change in the velocity of tornado with respect to that time. So what you have to do is you have to now plot here exactly over here now. Okay, so keep this as x. Okay, keep this as x. Okay, now you have to plot your tangent over here like this. Okay, exactly only one point. Now this tangent is the thing that is going to give you the change. Okay, that this tangent is the thing that is going to give you the change in the velocity. Okay, or yeah, with respect to time, which is going to be your acceleration. This is your velocity. Okay, so this tangent is the thing that is going to give you the change. I said you change everywhere. I'm using that word change. See, it has got changed from x to it has got increased, or it has got changed, everything same only. Okay, now I'm trying to make it over. Okay. So here now this is what the change is. Okay, this is what change line is. Okay, I hope now everything is little bit more clear than before. Okay, everything is more clear than before. Now you might be wondering over here, what is the error percentage? What is the error percentage? Okay. By the way, tornado is lightning fast. That means it will be just changing its velocity like this. Okay, for each and every second, its velocity will be changed dramatically. Okay, the velocity of tornado will never be constant. Okay, and also thank God, one point has got into my brain. Okay. Now coming back to here itself. Okay, I will say that point later. Okay, so that is what the tornado's velocity will never be just a constant. That means if it is just 1000 kilometers per second, it will never be just 1000 kilometers per second. For the next second, it will be like 1200, 1300, per 1 second will be changing a lot, okay, like that you can see here. So that since that here with respect to, you are actually calculating it with respect to time, here with respect to time, and over here you have calculated area with respect to length, okay, here you have calculated area with respect to length. So what you have to see is you have to make sure that dx is very small, okay, since you are calculating this area with respect to length, you have to make sure that it is very small. But here what you are doing, here you are trying to calculate, okay, here you are trying to calculate this change in velocity with respect to time only. So all you have to do is you have to make sure this time is very less, okay, time, this quantity here dx is going to be time, okay, here dx is going to be time, okay, so you have to make sure that dx, which is time, is going to be very, very less. So here you have, now you know that dx, which is time, which is just 1 second, okay, which is 1 second. 1 second is a very small time only comparatively with other units. Or you also take even each and every millisecond, the velocity of tornado will be also changing, okay, so you can also take it as 1 millisecond, because second is the SI unit, siege unit, everything, so I cannot take that. So we will keep it as millisecond itself, no problem, okay. So it is the millisecond, for 1 millisecond it is changing that much time. So here error percentage will be, okay, since 1 millisecond is very small unit, so that means dx is very less, so that means error will be also very less. You can just neglect the error, okay, error can be neglected, error can be neglected over here, okay. So that is what I am trying to shout. Now coming to constant, and also this is the reason, okay, this is the reason why differentiation of a constant is 0. This is the reason why differentiation of a constant is 0. What is the reason? See, if in case this x is not really increasing, it is just being as x itself, okay, x is not trying to move on, okay, x doesn't want to patch up, x doesn't want to move on, all x wants is to be x itself, okay. So in that time we cannot do anything to that x, so we are leaving it as such. See, if in case this x wants to become big, that means if in case this x wants to change, okay, then only we will be able to calculate the differentiation, because differentiation is the change, okay, differentiation is just the change. And if in case x doesn't want to change at all, then the total change will be 0, then that means differentiation will be 0. That is why the concept, I know nothing makes sense, right? Okay, see, this increase in length, okay, this increase in length is the thing that is actually determining the differentiation itself, okay. This increase in the length is what determining the total differentiation itself. If in case this x doesn't want to increase its length at all, okay, this x doesn't want to increase its length at all, then how can there be differentiation? Because there is no dx, then how will there be differentiation? I hope now everything is a little bit more clear. Okay, so this is the basic idea, about total differentiation, differentiability. Now we will go to differentiation, differentiability, which is very easy concept. Wait, I will just check whether I have left something. Nope, no. Now concept of tangent. Okay, my Maxer has explained this in a very beautiful way, concept of tangent, okay, very simple, very beautiful, and a very good way he has explained, but for that I want another 2 arms, but I don't have another 2 arms. Even carrying these 2 arms is a very great deal, okay, using these 2, so another 2 is not possible. It's okay, so I'll give you in the Oxford mathematical way itself. Okay, so one second. Okay, so I was trying to do something, but I don't know how well it has come. I will show you. Okay, I was trying to do some animation sort of things, but I cannot do it very properly. But okay, let's see how has it come. Okay, so nothing, just undo and redo. Okay, see here you can see that here this is a curve. Okay, here this is a tangent. Okay, so not a tangent, here this is a curve, sorry by the way. Okay, so this is a curve, right? Over this curve I have chosen 3 different points, which is Q, P, R, P, Q, anything, okay? So Q, P, R I have chosen, and where this P point is at X distance from the, at C distance from the origin, sorry, at C distance from the origin. So this P point is actually on C at X axis, okay? On X at C point, okay, on X at C point, okay. Over here you can see that this R point in x-axis, it is on C plus H point, okay. This Q point on x-axis is at actually C minus H point, okay. So these are its respective points, okay. My leg is paining. Okay, so this is Q, P, R. Okay, so now what I'm trying to do is I want to minimize this distance, and also you just check, okay, this is the x point which is C plus H, and the y point is f of C plus H, okay, and this is actually for this P point, this is what their x, so x is actually C and y is f of C, okay, and x is C minus H and y is f of C minus H, okay. So I've got all of them, Pakka Super 10. Now what you're trying to do is what I am trying to do is I want, and also this C is actually H distance away from, okay, H distance away from here, okay, that means after H distance you can see this R point, and also after this side, if you're going in the negative x-axis side, it will be minus H distance, okay. Akka, fine, done, super, amazing, well and good. Now what I want to do is I want to minimize this H distance. That means, see, actually it is a very zoomed version, really zoomed version. In reality, if in case here C point now, then H point will be very close, like this much here even. Okay, so just like here even you will be able to see H and C plus H, and here even C minus H. There is no doubt in that. Okay. But this is just a zoomed version because of some eyesight problem I have, so I have zoomed it, okay, and also you can all understand it in a very good way, okay. So now what I'm trying to do is I'm going to minimize this H distance, that is I'm going to bring this Q near to the P point and R near to the P point. So that means I'm just trying to make these two lines flat. If I'm trying to do that, then what will be happening, you can see that, see, first I will choose this line, okay, first I will choose this line, oh, this is white color, wait, now I get it, yeah, I did that animation a little bit wrongly. See, now, there is actually, what I'm trying to do is I'm going to choose this line, okay, I'm going to choose this line, and I'm going to reduce this, okay, I'm going to reduce this line to like this, okay, so which means, wait a second, okay, so give me some more time, I will do something more better. Okay, so now I've done this animation far more better, okay, I personally feel it like, okay, so what I've done is, see, this is, as I explained, these points are like this, and I'm going to minimize this H distance. That means H is tending towards 0, okay, that means what, H is tending towards 0, I will write that, now I cannot write, if I write, and then the animation will be over, yeah, okay. See, now that means what, as I bring this R point towards this P point, then that means this line, okay, and by the way, the line, okay, this line intersecting with this curve point is what known as R. That means if I just bring this R point like this, then the line will be like, it will be going in a decelerated way, okay, so you can see that, it will be now like this, okay, now here is the R point, okay, then after this, then this will be, then now here it will be when R meets P, okay, then also when I'm doing the same thing with this line, then it will be like this, okay, then the points will be like this, then it will be also C minus H comma f of C minus H will be like this, okay, like this, okay, so everything will be like this, okay, okay. So what I want is I have to calculate the slope of PR. Okay, I have to calculate the slope of PR. You might think, why do you have to calculate slope of PR, Kannan? It is actually very simple. This slope, okay, or actually if I calculate the slope of this PR, this slope, okay, this slope, okay, and then this one slope, okay, should be equal to the tangent. This slope should be equal to this one slope, and this slope should be equal to the tangent. And tangent is the differentiation. Okay, and tangent is what? Tangent is the differentiation of this total curve. Okay, this curve, for an example, just keep this curve as f of x. Okay, then the differentiation of f of x is going to be f dash x, and that f dash x is going to be this line. Okay, this line, this, okay, tangent is what going to be f dash x. So what I'm going to do, I'm going to repeat it again. Okay, so I am going to calculate the slope of this PR, then I'm going to calculate the slope of this PQ, then I am going to also equate it with the equation of the tangent. Okay, this tangent, then you will get it. Booyah. Okay. I don't know why am I this much weak, but my legs are paining miserably. Because from morning I'm taking video. Okay. Slope of oh god, then that animation has gone. Okay, so slope of PR. What is the slope of PR? So slope of PR is actually see the slope means what it means m. It means m is equal to y2 minus y1 whole divided by x2 minus x1. Okay, so if I'm putting these points, and then if I'm torturing it now, then I will be getting this equation. So this point. So this one only now I'm trying to calculate. Then it is going to be So what is y2? Okay, amongst here, what I'm going to choose as y2 is this one. Okay, f of c plus h. This is what y2. Okay, y2, and then this is what y1. This is what x2, and then this is what x1. Okay, this is what x1. Now I'm going to equate it over here, which is f of c plus h minus y1. What is y1? Is actually f of c whole divided by x2. What is x2? x2 is going to be c plus h. Okay, then minus x1. What is x1? x1 is going to be c. Okay, minus c. Okay, so now then c I'll cancel. Okay, then I'll cancel c. Okay, so at last I'll get the last mighty equation, which is going to be okay. So m is equal to no, not this color. Okay, so m is equal to f of c plus h minus f of c whole divided by whole divided by h. Okay, so whole divided by h. Okay, now when I'm trying to calculate for QP, so I'm going to minimize this total image. Also h has been chosen. Once again, okay, so now the slope is actually going to be of QP, which is going to be also m. Okay, so which is going to be again y2 minus y1 whole divided by x2 minus x1. So hereby I can equate it. Okay, while equating it, how will I equate it? Okay, so here what I'm once again, what is this? This is going to be QP, right? So QP, PQ or QP? Okay, here also I'm going to choose. Okay, this one as okay, y2 and x2. Okay, so that means what is y2? Y2 is going to be f of c minus h, okay, minus this one y1 is going to be f of c whole divided by, okay, so whole divided by, one second, then what? Okay. Oh, so whole divided by, here by what I'm going to write x2. So what is x2? X2 is c minus h. Okay, and x1 is going to be minus c. Okay, x1 is going to be minus c. Okay, now when I'm cancelling it, gone. So at last I'm going to get the mighty equation as mighty equation, which is f of c minus h minus f of c whole divided by minus h. Okay, and note this one point. Okay, this is the condition of differentiability, that for an example, okay, I will keep it as m, okay, as m2 and then m1, m2 and then m1. One second. The condition for differentiability is that m1 should be equal to m2. M1 should be equal to M2. This is notes. This color is okay, right? Oh wait, what happened? Okay. Okay, this is what the condition of differentiability. Okay, so condition of differentiability, that is P point. Okay, at P point. Okay, yeah, at P point. This is also important. At P point in sense what? At point P. Okay, so that means at this point P, okay, you have to check whether it is differentiable or not. Okay, to check whether it is differentiable or not, you have to use this condition, that is M1 should be equal to M2, where M1 you have to use this formula to calculate M1. Okay, and then to calculate M2 you have to use this formula. Okay, and then you have to equate them. When you are equating them, if you are getting the same formula, then well and good, super, you have got it is differentiable. If in case these two are not equal, then you will be able to know that they are not differentiable. Okay, and yeah, here minus h should come. Wait a second. So I will write here condition of differentiable in a little bit in a different way, in a little bit in a more appropriate way. Don't just use these two equations, use this one what I'm about to write. Okay, so that means it is going to be condition, okay, that is limit h tends to 0 plus, okay, that is f of c plus h minus f of c whole divided by h should be equal to limit h tends to 0 plus, okay, f of c minus h minus f of c whole divided by minus h. Okay, so this is what it is. Why h tends to 0 plus? It is actually h tends to 0 also you can write if you want. If you want h tends to 0 is also okay. It is because you can see that h is reducing. Okay, h is reducing in sense it is tending towards 0. Since it is tending towards 0, I can say it like this. Okay, I can say it like this. Okay. Still some more conditions are there, one by one I'm actually just saying. Okay, this video will be also as part 1 and part 2. Okay, now what I want is, now I want to prove the differentiation of, okay, sum number 1. Okay, question number 1. That is x square. Okay, I have to prove the differentiation of x square. Okay, so how will I prove the differentiation of x square? Use this formula. Okay, use this formula. See, this is to check whether they are differentiable or not. This is to check whether they are differentiable or not. Okay, and to find whether they are differentiable. Okay, whether and to find the differentiation. Okay, to find the differentiation, use this formula. That is limit h tends to just 0. Okay, f of c plus h minus f of c. Okay, whole divided by h. Okay, we don't care. We actually don't care whether here you use plus or minus. Here also you can use plus or minus. If you are using here plus, then use here plus. If you are using here minus, then use here minus. That's your wish because both are equal only, na? Both are equal only, right? Okay. Fine. Well, I'm good. Super. Very good. Amazing. Okay, I'm even appreciating myself. I don't know why. Okay. So this is what the f of x is actually. This is what f of x is actually. F of x is equal to x square. Okay, so at point C, so that means at point C you have to calculate. Okay, so that means what? Here x is equal to c, so hereby I can write it as f of c is equal to c square. Okay, f of c is equal to c square. Then also f of c plus h, I will write as c plus h is equal to c plus h the whole square. Okay, which is equal to c square plus h square plus 2ch. Okay, plus 2ch. Now I'm going to put it in this equation. Okay, in this formula, that is going to be limit. Okay, so that is going to be limit. Wait a second. I'll just choose a opt color. Okay, so this is very opt. Now then it is going to be f dash x is equal to this one. Okay, first I'm going to write this one. That is c square plus h square plus 2ch. Okay, minus f of c, that is going to be minus c square. Okay, whole divided by h, whole divided by h, that is going to be c square can be cancelled out. Okay, then over here, from here, okay, maybe take this one. Okay, so f dash x is equal to h square plus 2ch whole divided by h. Okay, now I can take h common. So if I'm taking h common, then it will be h plus 2c. Okay, is what actually here. Wait, I have forgot limit. Oh, how can I forget limit? Limit plays a very crucial role. You cannot remove limit. Okay, so here also I have to put limit now. Limit h tends to 0. Here also limit h tends to 0. And here I can remove limit, no problem. Because, no, here also I cannot. Wait. Limit h tends to 0, which is f dash x. Okay, so now if I have to remove limit, then that means what? Just put in place of h, I have to put 0. So which means f dash x is equal to 2c. Okay, that means what? That means over here, what is f dash x? Okay, what is f dash x? The differentiated value of the function. What is the function? Function is going to be x square. Okay, function is going to be x square. That means what? C first. In place of c, I'm going to put x. Both are same. Okay, so that means f dash x. Okay, f dash x is equal to 2x. Okay, now what is f dash x? What is f dash x? It is a differentiated value of the function. That means what? I can write it as, okay, d by dy of x square is equal to 2x. Okay, d by dy of x square. By the way, just note this one point. Very beautiful point this is. Okay, very, very beautiful point this is. Okay. That is slope, which is equal to dy by dx, which is further equal to f dash x, which is equal to y1. Then what else I can write? That's it. Till now, that is it. That is what coming to my brain. Wait a second, I will check. Still, is there any other thing? Where is that slide? Where is that slide? Where is that slide? No, not this one, not this one, not this one, not this one, not this one. Not this one, 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 not. Okay, so till now that's what coming. In future, if it is coming, then I will say. Okay, so there is a lot of things we have to discuss. Okay, till now that's it. Okay, that means what differentiation of x square is equal to 2x. Differentiation of x square is equal to 2x. By using this formula I've proved. So we are having lots of formulas, right? All those formulas like, okay, like for example, sine, differentiation of sine is going to be cos. Okay, differentiation of cos is going to be minus sine. Okay, differentiation of sec is going to be sec tan, and differentiation of tan is going to be tan, sec square. Okay, like that we are having lots of values, right? All of those, okay, all of those formulas have been chosen, have been taken from this from this formula only. Okay, every derivation. That means, for an example, just now I proved this derivation. That is, differentiation of x square is equal to 2x. Okay, this one I've just now proved like that. There are many formulas. Okay, in differentiation I'll be saying, wait, now even I'll write as much as possible. I will not write. I'll just give you all those examples like how they have come. So d by dy of sine x is equal to cos x. Okay, then d by dy of cos x is equal to minus sin x. Okay, I'm just writing with very bad handwriting. That means I'm going to erase it. So I'm just giving you. Okay, because by using this formula, in place of x you have put sin. Okay, in place of c you have put what, sin. Then mathematicians have done some processes, and then after taking the h out of that formula, then they have got this is equal to cos. And over here the same procedure. Then you'll be getting as minus sin x. Okay. And also here one important point that is from this, okay, itself, this is actually concept of tangent. I said that, yes, right. And over here I have to also take the, I have to say that secant. What is secant? Secant and chord are the same. Secant, na, a line that passes through point. Okay, that a line that passes through 2 points of a curve. Okay, that is what we will be saying it as secant. Okay, so you can just see that here it is secant, here it is tangent. That's it. So they both are related to each other. So that means I can say it as. Okay, and also another note point. Yeah, another note point. That is which color? Okay. No, not this color. Yellow color. Okay. So which means I can say that, okay, tangent. Okay, that means I can say it as tangent is the limiting case of secant. Okay, tangent. Okay, is the limiting case of secant. A function is said to be differentiable at point P. It has a unit. Yeah. So some conditions, we have to also see some conditions. No, not correct, not opt. Okay, so now it's time up. We will be meeting in another video. So that's it for today's video. We will be meeting in another amazing video. Till then, bye bye.